Hi friends, welcome back. We're going to talk about another exciting center of a triangle. In a previous lesson, you learned about your circumcenter. Today we're going to talk about angle bisectors and where those meet. So before we begin, let me go ahead and clear this out of the way. And how I'm going to show you, remember again, we have three types of triangles, right, acute, and obtuse. I'm going to start with our acute triangle here. Here's our cute little triangle. And what we're going to do is find the angle bisector. Now the angle bisector, exactly what it sounds like. It's an angle that gets bisected right in half, right? The definition of bisect means cut in half. So the way that I do this when I'm folding these triangles is I'm going to do this angle right up here, and I take them and I go right in half by matching up the sides, right? We do the best that we can here. Match up the sides. Okay, bam, let's get that nice crease going. All right, now I'm going to do this angle right here. This is a hard one because it's super skinny. So you'll see that again. I'm going to match up the sides if I can fold this. There we go. Whew. Fold those guys up by matching that side. And then I've got this angle over here. So I want to match that one up. And we're going to do the same idea. We're going to, okay. So you gotta make noise, otherwise it doesn't count. Now you've seen that I have created, or I've taken these angles, I've cut them in half, and they all meet in the center. Now this center, our previous one was called circumcenter. This guy right here is called our incenter, Now I will give you some notes towards the end, so you don't have to write that down quite yet. I just want to demonstrate that for you. All right, in a right triangle, we're gonna do the same idea. Let's start with that big right angle. That's nice and easy. We're going to match these angles up, or these sides up right there, so that we can cut that angle exactly in half. We're going to do the same over here. This is that super skinny one. Those ones are hard. Maybe do it this way. Okay, and if we fold this guy right there, kablam. Again, the noise is absolutely required in order to make these work. Just kidding. You don't have to say that. All right, let's match these guys up. There we go. Okay, now I have folded those. Oh, that one's going to be a little bit off because I didn't fold perfectly. Luckily, I'm going to show you how to make these perfectly when we construct them. Okay, again, for my right triangle, I've got an incenter right here, right in the center there. All right, one more triangle. We have an obtuse triangle, and woo, this is going to be hard because these are some skinny angles. So I'm going to start with the big angle, right? That one we get folded in half by matching up those sides. Fold. Now this skinny side, I think it's easier if we do it this way. We're gonna go right down. Okay, and I think there we go. Woohoo! Got that folded. Looking at, make sure I'm not off the screen there. You're like, oh. All right, let's get this other skinny side. Okay, and we've got that one. All right, not perfect again, but I'll show you how to do a good one. So in our obtuse triangle, you'll see that our incenter is right in the center there. Now you notice, unlike a circumcenter, for our incenter, they all occur in the triangle, So before we get into some definitions and some explanations, I want to show you how you can construct these. So I've got this triangle here. We're going to do it with my handy compass and my handy protractor. What I'm going to do is start at one angle. In the previous one, you had to be halfway. You don't have to do that for this. You just have to have an angle. So I go like this, but I do want my angle to go across both sides there. So for my angle A, it's going across AB and AC. And I come over here and I go and I put it right on this intersection here. And I draw a line like that. Go over here, do the same thing. Notice I'm not moving my compass at all as far as the radius or the distance here. Okay, so I've got that point and that point. So what I mean by that is I have a point right here and I have a point for my A. So now all I have to do is use my straight edge and line up those 2 points, this point here and my vertex. And we say, okay, there we go. That looks about right. No, now I'm all nervous. Okay, there we go. Perfect. Okay, so we've got that guy right there. Now let's do our B the same manner. We put our compass down, we draw it across BC and across AB. We meet those intersections and we draw another one right over here, like this. There we go. And then we come over to this one. Oop. and we don't move. We don't get excited. Just kidding, you can get excited about math, especially geometry. It is fun. All right, look at it, matches right in there. So I'm going to go to my B and to here, that point, and I'm gonna go match those up. Beautiful, okay. If your paper gets messy, you can erase some of your markings, but you can leave them there too, that's fine. And notice I'm moving my paper, not the compass. It depends on your compass or how comfortable you feel, but I like to move the paper instead. That's why I trimmed it so that it doesn't hit my camera there. All right, so again, I put my compass on point C. I drew a line through AC and BC. Now I'm going to draw another arc. I didn't draw a line, I said line, but I meant arc. And then do the same on this intersection here. All right, here we go. So now I've got a point right there, and I've got the vertex at C. So I'm gonna draw this all the way across here. Let's line those puppies up. All right, there we go. So this, friends, is our incenter, and that's far more accurate than folding, especially when you have those really tiny ones. So that is our incenter of this triangle. Now let's take some notes for that. So for our incenter, it is created by angle bisectors. And now the other important thing that we have here is on a right triangle, on an obtuse triangle, and on an acute triangle, they are all inside the triangle, inside the triangle. I also have another interesting theorem here. The bisectors of the angles of a triangle are concurrent at a point equidistant from the sides. What does that even mean? The bisectors of the angles, so the angle bisector, occur at a point that is equidistant from the sides. So if we've got this guy right here, what that means is I'm gonna use my straight edge again, and I'm gonna take this and this, I'm gonna use, let's use a different color highlighter. There we go. And so that means that all of these, if we go from our incenter here, right, and we go straight out at a 90-degree angle, that it's going to be equidistant from the sides. So the best way to draw that would be, 90-degree angle. You're gonna kind of see that it goes out like this. So essentially, let's see. That's more like it. That's more like a 90-degree angle. I could measure it with my compass, but we'll just do that. Okay, and then from here to here, we want it to be 90 degrees. So we're gonna say, okay, from here to here, 90 degrees. And if it's slightly off, just pretend like it's 90 degrees. And then from here to here, that's fairly accurate. Maybe like more like this. It is gonna be 90 degrees. So basically from the center out touching the walls, those are all gonna be the same length. They're all congruent. I kind of messed that one up a little bit. We'll pretend that's a 90-degree angle. Okay, so that's what this theorem is. Make sure that you notate that in your notebook, and remember that the magic word here is incenter. Incenter is created by angle bisectors. Have a good time, and we'll see you next time.